looking at whether it is normally distributed. So we also need to learn whether our distribution is normally distributed. If it's normally distributed, issues of outliers, extreme values, and those things will not happen. You will see that the dispersion will be very low, and then you will not see extreme values influencing the average. Now you also need to be sure that there is a relationship between the two quantities. In fact, when you are dealing with correlation, you should be guided by theory. You cannot just go to your house and say, well, my wife, now I've learned correlation, how to find association between two quantities. So I'm coming to look at the correlation between the quantity of salt that you put in my soup and then my results. So when you compute and there's correlation, then you go and tell your wife that next time, put more salt in my soup so that I can perform in exams. There is no relationship. In fact, theoretically, you cannot deduce relationship between the two quantities. It's very difficult for you to deduce which the quantities, the relationship between salt quantity in your soup and results. But for example, if you want to look at interest rate and inflation, theoretically we know that there's a relationship between the two, and it could be depending on the situation. The theory posits whether there's a positive correlation between the two. In some cases, you can get a negative association, but it's up to the data to tell whether there should be, and then you look at the other diagnostics and see whether they do make sense. So you should be mindful of the relationship. You cannot test anything that you wake up and say, well, let me look at the number of people in, say, in our market, or Tamale market, or Bolga market, and then the number of military personnel that American is sending to Middle East. Then you say, I want to see whether there's correlation. So what is the link? There should be a link between the two. So that is what we are talking. That's what we are referring to as that there should be a relationship. Okay. Now there should also be homogeneity of variance. We don't expect that the two quantities, the variation in the two should not be that wide. I mean, the dispersion within the two quantities that you are dealing with should not be wide. So standard deviation in A and standard deviation in B should not all that be wide. Okay. So those are the basic assumptions. You can get those assumptions from your manual, page 83. It's in there. You can get those manuals. Okay. So as I indicated, you have to be aware of outliers. So once there is extreme values, those that will widely influence the results, it could cause the result to be misleading. So we need to be mindful of that. Okay. Now, as I indicated earlier, I said the correlation is measuring as linear association. For example, if you look at this one, there is a relationship, but that relationship is somehow curvilinear. It's a quadratic in nature. It's not that there's no relationship, but if you compute the correlation coefficient of this, you are likely to get 0, and does not mean that there is no correlation. There's no relationship. There is some sort of relationship, but that relationship is not linear in nature. So we need to be also mindful of that. Especially, we can also get something like this. It's not. This one also is showing a bit somehow linear, somehow not, and then we can also get something like that. So in all cases, you need to be mindful of what you write. So if it's a linear association and we just write association, you could be penalized. So you need to be mindful of that. Now, Pearson product correlation coefficient can be computed by using this formula. I think that is the most commonly used ones. Or you can also decide to use this. And that's also translating to standardize. You can standardize and find the z-scores of the two, and then just add them together and then find the average, and that will give you the correlation coefficient. So we can compute that, but don't worry, because we are not going to do a lot of manual computation. Most of them we are going to use statistical packages to run the regression, to run the correlations, for you to interpret. So yes, you should know what it is, but you should not be much scared with the complexity of this formula, because you are not going to do it manually. Let me take you through now a small exercise, and then we can probably do further interrogation. Let me demonstrate, do some small demonstration, and that demonstration will indicate what we mean. So for example, this is a typical example of a relationship. Now we are not moving on to nonlinear relationships, but rather we are ending at linear relationship. So let me then illustrate, use the SPSS to illustrate, and then further illustrations and further explanations can be, we will get further explanations from our demonstration. Now let's come to this, our data. This data has been used severally in our class. So this is the data we are using, and you are familiar with this data. So it's the data that we collected during a conference of about 180 participants who were randomly selected. Sorry. And we have statistics for a number of indicators. So let's assume that you want to see a correlation or association between some indicators here. So the indicators we are going to look at are let's look at life expectancy, let's look at human development index, let's also look at intolerance for corruption, let's also look at adult illiteracy rate, then let's also look at quality of life and life expectancy. Okay, we have life expectancy already. Okay, so we have these indicators. So let's go to our data and look at these indicators. So if you want to compute correlation coefficient, we will go to analyze. Now when you go to analyze, you come down, you look for correlate. Under correlate, you go to bivariate, because we are looking at two indicators pairwise. Now when you get this, we then push list the indicators we want to look at. So we said we have life expectancy is here, adult illiteracy is here, level of intolerance for corruption is here, we have human development index is here, then we have quality of life. Now once we do that, we indicate that we want to look at the Pearson correlation coefficient. We go to our options. We can just click continue. You're looking at pairwise. Now when we click OK, we will get this result. You get the results, the correlation coefficient results That is the correlation between life expectancy and life expectancy. Anytime you compute correlation between a quantity and itself, the resultant answer will be equal to 1 because they are strongly related, the same values. Okay, then you have life expectancy against adult illiteracy. We have life expectancy and intolerance for corruption. We have life expectancy and human development index. We have life expectancy and quality of life. Now, under this, each case, there is a hypothesis being tested. And the hypothesis we are testing here, is, let me introduce one. This thing there. Hypothesis we are testing here is that if you look at life expectancy, let me use life expectancy, denote life expectancy by, let me denote life expectancy by LE, adult illiteracy by AI, intolerance for corruption, let me call it CPI, quality of life CL, human development index HDI. Now we are computing correlation coefficient between LE and AI. Then we have R, LE, CPI. We have R, LE, quality of life. Then we have R, LE, HDI. Then when we finish, we look at R, AI, CPI. Then we have R, AI, QL, in that order. Now, in each case, we are testing a hypothesis. And that hypothesis, our null hypothesis for each correlation we are testing is that the correlation coefficient is equal to 0. That our R, our H naught, is that the correlation coefficient between adult illiteracy and life expectancy and adult illiteracy is equal to 0. And the alternative is that our R, which is between life expectancy and AI, is not equal to 0. So this is the hypothesis we are testing. And per our what we have done so far, our hypothesis testing, we said that you always reject the null hypothesis when our p-value is greater than 0.05. That is our sig value, our significance level. So, and then conclude that the alternative is true. So on the basis of that, if you go back to the our correlation coefficient results, if you go to our correlation coefficient results, this is the coefficient. This is the coefficient. And this coefficient indicates the strength of the association. Per Cohen's classification, this will be classified as what? Large. If you have forgotten the classification of Cohen, you can refer to page 82 of your manual. And it's there. The range negative 0.32 is classified as large. And then we can also, this second value is looking at, the first part is looking at the correlation, the second is looking at the significant value, and then this, and the last n is corresponding to our total sample size. So you first look at the hypothesis. The hypothesis that this correlation coefficient is not different from 0, and our probability value here, or the sig value here, is 0.000, which indicates that we should reject the null hypothesis that this value is not different from 0, and therefore this is not 0, this one is significant. So we can then interpret the results and look at the negative and look at the coefficient. The coefficient here indicates that there is a negative correlation, and that correlation can be classified under according to Cohen as large. The same way, so between life expectancy and adult literacy, there is a large correlation coefficient, a negative large correlation coefficient. Now between life expectancy and intolerance for corruption, that one too is large and positive, and indeed is also significant. This one too is also significant, and that one too is positive and large. This is also significant. So in all cases, we see all of them as significant. The association or the relationship between all the indicators are significant. Okay. So on the same vein, you can also interpret the relationship between adult illiteracy and the level of intolerance for corruption. And this is the correlation coefficient. It can be classified as also large. If you come here, quality of life and corruption can be classified as moderate, because we are saying that from Cohen's classification, when you get anything between 0.5 and from 0.5 to 0.69, is classified as moderate. So you can refer to your manual page 82, and in page 82 gives you the classification. And so basically that is how correlation coefficient is done, and that is how they are interpreted. So you can, in terms of write-up, you can refer to your manual, and how it should be reported is indicated. You can get that one in your manual. But let me take you through the steps again in estimating the correlation coefficient. I say first you go to analyze and go to correlate, go to bivariate, click on that. Now these variables initially will be here. So the variables you want to test, you can push all of them into the test variable box. So we have this, we just click here. We have life expectancy, you can put them here. You have level of intolerance for corruption, you put it here. We have human development index here, you put it here. Then you have quality of life, then you put them here. Then you click OK. When you click OK, this table results will be produced, and that is how we produce correlation coefficient. I hope you are okay. If you have any further questions, you can read Pearson from page 80 through to page 84 for further clarification. Note all your questions down and meet us in class for discussion. Take note of these issues. We are not going to repeat this lecture. We are going to just discuss the issues and your difficulties in following this video. Thank you.